Hello, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Somehow I still have hiccups now after a night of sleep. I don't get it. Something is wrong here. Good. So last session we did some progress here. By adding those types, yeah. Before we jump back into this, let's check what is new on GitHub. I know that there are a lot of pending changes that haven't been merged yet. So like unassembly's branch is still not merged into mainline. The bunch of changes from why can't I? Okay, now it works. A bunch of changes from Mr. Genius, aka Dev Genius Code. Let's call him Mr. Genius. It's a very strange Dev Genius Code. That's strange name. Let's just call him Mr. Genius. This makes more sense, right? Okay, so he added this. I haven't seen this, and I think he also has some older change somewhere here. This one. Let's take a look at this. What is this? This PR introduces support for right to left languages in the handling of generals. STR, let's see, eliminates the need to manually reverse text when working with these files. RTL reverse. Let's see. Build GameText Compiler. Okay. I'm surprised that this is apparently necessary. Okay, what do we have here? Conscast. Oof. Why is there a conscast? No, this is suspicious. Constcast. I mean, a constcast should always sound the alarm bells because, I mean, there are legitimate use cases for constcasts. Like if you have like a non-const function and then you make a const function, and instead of re-implementing everything that the non-const does or the const does, you just like constcast this pointer and call the const function, and that's typically fine. But here, what could that be? So he changed. Okay, so you changed write str file. You removed the const here. Why? Oof. Okay, so the problem I see here is this the text must not be modified here. Let's say, right, let's put this here. The the past text string must not be modified here. The past text string must not be modified here. Create a new copy. Create a new string when RTL reverse is set. Better. C++, CPP. So it should be something like if this, then let's make this larger. So there should be something like this text. Let's make it reversed text or just reversed equals text, and then reversed reverse string, and then str str translate text str reversed else this, right? Right, because the problem is here, if you would call this function twice now on the same text string, then you would reverse it once and then you would reverse it again, right? So on the next write, it is not reversed, right? So it flips every time you write in your file, right? So you have a single language, the option is set, and then you write two different files, and then in one file it's reversed and the other file is not, and it will always flip the amount of files you write. So this should not happen. And also, like, typically when you have like a write function and you give it a text, then typically the text is not supposed to be mutated, right? You give it the data, please write this data. But you don't expect the function that writes it out to also modify it, right? Just logically speaking, it's generally true that when you pass something to a function that is just supposed to just write it out or show it or present it to the viewer, then it should not modify it. Like there should be always a clear separation of responsibilities. If you want to modify a string, then it probably should not be in a write function, right? It's having too many responsibility, this write function, right? So yeah, I think there's an easy enough fix for this, right? Let's start the review. Yeah, and then he can also revert all these const changes. Okay, what do we have here? Reverse string. Oof. Yeah. Oh. Okay. void reverse string. This would have to be this will need to be documented as being Thyme specific. Also can simplify name to just reverse. Reverse. Does std string also have a reverse? Std string, basic string. Let me see. I don't think it does. It has a reserve, which has the same characters as a reverse. Reverse. There's a reverse iterator, but there's no reverse function. Std string reverse. Std reverse. Oh, sorry. Expand all. Get buffer for read. Oh, trim. Okay, what does this do? Okay. Yeah, so yeah, so I suspect this is correct. This get buffer for reads. It's the name of this function is a bit misleading, right? Because you're actually also allowed to write to it. So Then the name of this is misleading. It should be get buffer for read and write, or just write. Because this implies that you can only read it, but you cannot write it. But you can actually write it, right? So it's kind of misleading. Okay, but in this case, all right, if it's 1, you don't need to reverse it. Yeah. Get buffer for read. I don't think that this is correct. Hold on. So this here, this. So I line enumerate lines. Join reversed. Hold on. For I line enumerate lines. Lines. Arabic is written right to left. In STR, all lines are reversed. It is impossible to read. Maybe it would be beneficial if in STR each character in a line was reversed, so that Arabic speakers can read and edit the lines. Okay, it would be beneficial in STR each character in a line was reversed. Arabic is written right to left. Right to left. All lines are reversed. Lines string.split. String.split. Okay, so it certainly needs to be reversed here and not over the whole thing, right? That's one thing. Split lines. Okay, enumerate lines. Reverse line. Okay. So reverse string. Good. So we add a second comment here. This reversal is not quite right. ABC XYZ would need to turn to this reversal is not quite right for Arabic. ABC XYZ would need to turn to CBA and ZYX. Right now, with current implementation, it turns to X, no, Z, Y, X, N slash CBA. It looks to turn to this would need to be documented as being also can simplify to reverse. Good. So this is at review comment. So this code here starts smaller than ends. Start smaller than end. I think this can be simplified with std swap. So get buffer for read will make a copy of the previous buffer. Probably. Let me see. Well, we need to go in here. There we go. Okay, so if it's not yeah, str copy. New data peak. Okay. Okay. Yeah. That should work. Yeah. Okay. Yeah, so where is it? Yeah, so it's probably correct. Data null pointer return, yeah. It's probably correct for the most part, yeah. Okay. Come on, see this first. Okay. Yeah, okay. Okay, I think that's enough for now. Submit review. Okay, good. Let's take a look at the other one. Implementation of modifier converter engine. Okay. What is this? Game model converter. Ugh. Okay, what does he want to do here? Okay. Okay. It's easy to lose overview here because this change also contains GameText compiler as if it was freshly added, but it's not quite right. Okay, so we need to focus on this here, game model converter. Right. Maybe it would have been better if he make the branch on top of GameText compiler branch, built on top of that. Maybe. Okay, but this doesn't matter much. It's work in progress. Okay. Well, maybe we should have looked at the diff that we had before. How do we get that back? How can we view a diff here? Jesus Christ, something's loading very slow. Let's see. Guess you can do it like this. Yeah. Okay, so this shows us what he has added recently. Yeah. Let's see. So he added root chunk, chunk manager, chunk loader. Read that, write that, options. Okay, what is this chunks manager? Chunk info, name type, data value, chunk pointer, chunk list. Here you can reuse the, you could use this type here. Okay. Chunk manager type. Load save. Dump subchunks. I think dump subchunks. Dump is, I think, not the right word here. It should be write subchunks. If it's writing, not, it's not dumping. It's maybe that's a write function. Serialize. Write. Oh no, it's write chunk info is here. Read chunk info. Write serialize subchunks. Dump subchunks. Why don't just call it write? Is it writing or not? Yeah, write. Just make it write and make this read, because it's reading here. Chunks manager. I don't quite understand the motivation here. This is like a wrapper around the IO, the chunk IO. Maybe. Not sure. Maybe it's to just like get the chunks, create the chunks. Could that be? Here. Yeah. That could be. Mm-hmm. Mm-hmm. Yeah, so he builds a tree of chunks and they are like persistent, and so then with this you would be able to modify them or yeah, save them as different formats. Okay, that makes sense, I guess. Maybe it can be renamed to chunk store, chunk. Yeah, I know. Chunk func map. Well, it's a very much work in progress, so I won't review it much here. Just take a general look if there's anything big wrong. Okay, deleted a lot of stuff here. So basically he replaced all his previous chunk reads with the new chunk manager. Okay, I see. Okay, but basically what he needs to do now is he needs to like also interpret the chunks, right? So what does he put there right now? A subchunk, chunk, chunk size, chunk type, chunk info, name type, data value. I don't know why he's using so many unique pointers. Like why does this need to be unique pointer? Like here you could just inline this chunk info, put it in here, right? Or is this like option unlikely? Is this likely to be null? Only if this is likely to be null, then you would do it like this. Otherwise, if a chunk always has this data, then either just put the chunk info in here or copy this stuff and put it into this chunk as well. Unless there's some other reason that chunk info needs to be separate from this. I'm not entirely clear, but right now, to me, with all these unique pointers, it looks a bit too much unique pointers. The problem is that then memory will be all over the place, right? It's not tightly packed together, and that makes reading, accessing data more inefficient, right? So try to like put it together, I would say. Yeah. So what does this do? This function? Chunk factory. Oh, I haven't seen that yet. 1,800 lines of code. Chunk factory. I suspect that he copied a lot of stuff from the W tool as a baseline. That's my guess here, but let's see, serialize. What is this here? Looks like a Hebrew, maybe. Chunk. Okay, I just yeah, how much is the 116.53? Yeah, or 175. Yeah. I just hope that he reuses as much as possible from actual Thyme code. I think that's important to be closely tied to Thyme code first, and then have everything else that is not a chunk read or write that is not in Thyme, then put this here into the chunk factory, yeah, or elsewhere, right? So I expect not 100% of chunk read functions to be served by this class here, because then it would mean it's disconnected from actual Thyme code. But they ideally would need to be in sync, right? Yeah, just something to keep in mind here. Maybe yeah, but maybe that's work in progress. I don't know. I won't make a comment yet. If I see that, well, hold on. Is it already using the chunk factory or not? I don't know. There's this here. Okay, there's this, and Chunks Manager has this. Is it already using this chunk IO funcs? Read func. I will add a comment here. Maybe, perhaps, prefer read write name instead of dump serialize. Serialization actually means read and write, and dumping is typically dumping on disk. Dumping on disk or display. Disk or, let's say, view. Initiate chunk func map. Let's see. It's outdated. What does that mean? It's obsoleted. Okay, let's open Thyme code real quick. So let's search for this. Okay, so prototype class. So boah, Mann. Um, Three chunks. Load W3D. So okay, so so for example, let's search for let's search for this one here. Yeah? Triangles. Here. Is obsoleted. Why? My gosh. Okay, so I think this is a good example, this class, mesh geometry class. So my expectation would have been that we try to embed the loading and the writing of a file inside the mesh geometry class, for example, right? So you have this guy, and you can load it from W3D, right here. But then you can also save it here, right? Now this is a virtual function, so that's not very pleasant. Why is that virtual? Because of this? No. Why is it a virtual? It's not an override? Okay. Yeah, the write W3D would not need to be. It must not be virtual. Load W3D. Yeah, so wait, let's look in here for some other example then. Read chunks. Okay, let's for example look at vertex influences. Yeah. Okay, chunk array, dump serialized chunk array. Read influences. Get bone links. this file is 4,000 lines. So this dump serialized chunk array, what does this do? Here, dump name, load data, chunk data. Can use a reinterpret cast here. Read chunk data. Yeah. Okay. Add data. Yeah. So there's now a lot of macro magic, right? Which makes it hard to maintain. Oof. So let's add a comment here. This means that this code is not tied to Thyme internals. If the format was to change in Thyme, then this code, well, if the format, let's say beyond the struct, was to change in Thyme, then this code would be outdated. Are we okay with that? Yeah, I don't know. It's a tricky question. I mean, the problem is that the Thyme internals, they are sometimes hard to reach, right? So here is a mesh geometry class. You basically need to create this class and then read it, and then you would then need to have like a safe. Yeah, it would be more complicated maybe. Yeah. I thought it would be much more complicated to embed it in here. Yeah. So for example, so here, mesh header. So, yeah, see, like this here, there's all this extra logic here, which needs to somewhat replicate the logic that is in here, right? Like obviously this class does a lot more. Like it actually, you know, creates more internals and creates bounding boxes, spheres, and I don't know what else. A lot of stuff. But if if this code here was more tied to Thyme internals, then all this wouldn't be necessary here, right? So, but yeah, it's tricky to do. Maybe the comment I edit should be more closer to here. Let me remove this here. Let's put it here. This means that this code is not tied to Thyme internals. So in this case, the Thyme internals would be this class, right? In this case, if the format beyond, if the format, if the contract in this class changes, then this code would be outdated. Are we okay with that? Can we perhaps tie these things together to achieve consistency with Thyme internals? Basically, I I would like to ensure that our W3D files are always in sync with what actually Thyme expects them to be. Oops. This means that this code is not tied to simultaneous. Basically, it would be good. It would be good if our W3D files are always in sync with what Thyme actually expects them to be. Yeah. Okay, so this is my only worry here. Other than that, I mean, it's fine to, you know, like if all is correct, then that's already good. But yeah, there's this disconnect, right? So it's not like basically you would always need to manually maintain when you change Thyme, you would then also need to maintain all the tools that implement W3D format custom, right? You need to pick up all tools that do something with it, right? And if you miss one place, then there's an inconsistency, and then you run into either big bugs or subtle bugs. Maybe bugs you don't really see unless you spot the bug in the game. Maybe it could crash in some other cases, right? So yeah, like as long as W3D doesn't change ever, then this is stable. But if there would be some fixes, improvements, additions to Thyme's W3D, then this breaks, right? Silently or catastrophically, right? One way or the other. But if they were guaranteed to be in sync, and this would always like depend on what Thyme does, then yeah, then there's less chance of breaking, right? So that's my worry here. Yeah. Other than this, I think maybe this should be here, this dump. Where's it? Ugh. I don't know why it didn't copy that thing. Here. What is this here? Oh boy. Jesus Christ. There we go. Dump subchunks. Okay. So I think this one he can make a template function because it takes a type. I think you can make this macro a. You can. I think you can. I think you can change this macro to 2 template functions. Yeah, and then basically so something like I don't know if like this would compile whatever right now, but so you have tag template type, right? And oof. Oh boy. I don't know why it's so big. Okay, template, and then void dump. What let's call it. What is it? It's load, right? Read. Yeah, reads type, right? And then you put these guys here, and then you say these guys here, right? Remove these guys, and then you give it. You need a name and a type. So you put here, what is it? Const char name, I guess. Name. Const char. Add data. What is this? Add data. It's not in here. Add data. Add data. Here. Here. String. Type. String class type. Okay, how's it called? Yeah. Const char name. So it's name. Then here you have type. Yeah. Dot read type. I think this would work. And then you can have like a function like this one here. Which then does reads reads void reads could read O and then basically you pass this data this and then this and then this okay, and then here we would do retype and then take this struct here, put it here, and then cload data and then this name here, right? This way the code could actually be debugged. The code can actually be debugged. Generally, it is a good idea to avoid macros for function code. I think this would work. Maybe there's some compile error somewhere here. But in a nutshell, roundabout, yeah, and this can also be a reinterpret cast instead of a C cast. But yeah. Okay, what about the other one though? Yeah, I mean, this one can also be this one can yeah. Yeah, I see the reason for those macros to just have really simple one-liners, right? So yeah, here he ends up with simple one-liners, right? Yeah, I don't know. Yeah, I don't know. I mean, the problem is it's really hard to, like, you can't debug this, right? If you put a breakpoint here, you can't step in, you can't see anything, what happens. So it's a bit of a black box, this code. But yeah, if you actually write this as proper functions, then you just have a lot of extra code, right? A lot more code. So, and then maybe also more errors when you make errors on those duplications. So yeah, like here, like, okay, you have this function, but then you have a wrong string here, right? Or a wrong string. Because right now the string here in the macro is generated from this name you pass for this and for this. So you know that they are in sync. So I don't know. Let's yeah, you could change. But I see here the goal is to reduce the code a lot. But maybe there is still a way to reduce macro usage. What you could also do is at least take parts of this out. Like, so for example, he could at least take this out and put in a template function, right? So he, and this, so he still keeps like this and this in the macro, but the function bodies itself are not. Maybe. Yeah. So you could create the template function like this, and then still have a macro. How do we write this? Or so it would be template this. Okay, so we need to copy this here. So let's put here. So it's right type. Maybe put capital T here. I'm missing a comma here, by the way. Comma. Let's put here T. Okay, and then he could have here serialized chunk array. And here you could say retype cload data, and then name, and then another line. Read. So this is reads, writes, writes, or make it half template, half macro. Yeah, I think this would already be a little bit of improvement, right? The macro becomes less dominant. You have like these template functions. And then, so you can at least step in a bit of code, right? You can put a breakpoint here, right? So maybe this would be an option. Yeah. By the way, we're missing something here. How do I edit it? Update comment. Edit. There's missing here a type. There we go. Oops. Type. Update comments. Yeah. Also makes it a bit easier to read. And yeah, I wouldn't use dump and serialize for, so dump is read and, oh wait, what is dump? Hold on, I'm confused. So here dump is parsing. So dumping is reading, which is weird. Yeah, dump means reading here. That makes no sense to me. So I would rename, get rid of the dump word and use read, and use write for writing the chunks, and then use serialization for read and write, right? So yeah, reads, write, and both together is serialize. Yeah, that would be my suggestion here. I think we had another comment about this somewhere. Where did we put it? Oof. I don't know. Here. So original. Wait. W-dump uses dump for reading. I think it uses it because it does actually dump it here. It does print it and so on, right? W uses dump for reading because it reads and then writes it out. Or writes it out. Prefer read write terminology instead of dump serialize. Serialization actually means read and write. Dumping is typically dumping on disk. Let's remove this. I think that's a better comment. Yeah. Okay. Yeah. So I think we had 3 comments, right? Yeah. So yeah, the big points are the naming, dumping and serialization is not great. The macros are not so great, and yeah, the disconnect from actual Thyme code. I think that's the biggest problem. But yeah, there's no easy answer. Like, if you don't want to have this disconnect, then you need to embed the Thyme code somehow. So, which can be difficult, but it would give the most stable results in the end, right? And it would be then actually really true to what Thyme actually reads, right? So yeah, right now it's disconnected from Thyme, which can or cannot be a problem. It's not a problem right now as long as all this code here is correct, but it will be a problem when we touch Thyme. Then this code will be outdated and there can be problems, right? Yeah. So it's, I guess, something to look at. Now there's another complication, like what if the W dump does knows additional things on top of Thyme, right? So Thyme is like an older W3D format, and there were games after it. So maybe the W3D format was changed in the process, right? So Thyme could be outdated format, but still, the W3D in Thyme is the most important format because that's the one that we need to load the game assets, right? We don't care as much about other formats, evolved formats. So it needs to be true to Thyme, right? I'm not saying that this code is not true to what Thyme does, but there's no guarantee, right? That's what I'm seeing. There's no guarantee here, right? But it could, of course, be all correct, right? And I mean, the code looks good. Like it's easy to read this, right? So the code is fine in principle, but maybe there should be a mode where you say, instead of going through all this, we actually read it through Thyme, right? When Thyme does have a load function, right? This is a save function. Here it's a load function. Yeah, right. So if Thyme provides a load, then go through Thyme and not through here, right? Perhaps it would be a consideration to have something like if W3D tie to Thyme internals, else, and if. Yeah, and then in here it will do this here, this, right? The code that is already there, right? Okay. And then otherwise, it will well, that's a good question. How would that be implemented? Oof. Since it has this chunk tree pointer, what does this contain? Chunk tree pointer. I think it was in chunks manager, right? Chunk info, name, type, data, value. Oof. Yeah, I don't know. I'm not sure how this would be implemented. Where instead, basically instead of data, instead of this data, yeah, I think I know. So right now we have here. So we were looking at this one, right? Mesh geometry. Okay, so what do so data. Okay, like this, dump if this, else this. There we go. And then here, basically it would do data dot load W3D. That was the name, right? Load W3D, yeah. And then what is the interface of that? Let's see. Here, load 3D. Load 3D and basically just passes. That's it, right? So that would be the load. And then you would have a save or write, and this would be a const data, and this would be loads and save, load save, right? And this would be save class. I don't know if, does it need to be C save? Okay, so C save const this save, and that will be C save data. And then here it would have the same, this dot dot dot, and this would be, does it currently take this one? Let's give it the same name here. Okay, let's look at this. Okay, so basically this is what it is right now, right? You have this dump class, aka load or read, and that will read the chunk, and then it will do its stuff. And then same for saving, right? And instead of having this, instead of using this tree pointer thing, we will have a mesh geometry class, which is passed here, and that it will load it. Otherwise, write it. Well, maybe it would be probably good to have still the chunk tree pointer here, but then how would you use it together? I don't know. Chunk tree pointer. Let's look at the chunk tree. Where's it? Here. Chunk tree. Wait, what was it? Chunk tree pointer. This one. Chunk tree. It's this. Which contains subchunks. It contains this. Yeah. The raw data type. Yeah, maybe the chunk tree. Maybe there can be like a. Wait, chunk tree is this? Chunk tree pointer. Okay, we need this here. Yeah, okay. This one would be a. Yeah, so if we probably need to have chunk tree PTR, but then inside here could be like a union of different kind of pointers, like this mesh class thingy, right? And then you have like a type, so you have like a plain chunk type, which is like what it currently does here, and then you can have like special chunk types, like this geometry mesh class and some others, right? And then you can have like a pointer in here, which you assign an allocation to, right? So let me draft that as well, because it's maybe not very clear when I just talk about it. So chunk PTR. So I would imagine, something like a union. Oh my gosh, union. There we go. And then in the union there will be this chunk pointer and the mesh geometry class. Mesh geometry. Yeah. And then here we put a I don't know if this can be in a union. It's a unique pointer. Maybe it has to be a raw pointer then. I'm not sure if unique pointer can be in here because it has a constructor, and I think union can only have primitive types. So this maybe needs to be a chunk. And then you can have here enum class type, right here, and it's type, and type would be like mesh geometry class or chunk. Actually, let's put this at position 1. Position 1 here. Right, and then here we'd have more dot dot dot, right? Right. Dot dot dot. Then you can initialize this to null pointer, and you can set this by default to type chunk. Right, and then yeah, and then basically here we can now also pass this and this, and then here we can say data dot data dot type equals chunk tree type mesh geometry class, and then data dot mesh geometry equals new mesh geometry class, and then this loads this, and then here you would say assert data dot type equals this, right? And then here data mesh geometry this. And then here, obviously, it would also need to maybe allocate something or so. Oh, wait, here. Dot, dot, dot. So this way, then the chunk tree would basically allow for different kind of containers. So not just this chunk type, but also use a representation that lives in Thyme, right? Lives in Thyme. Yeah. Yeah, the only problem is then, yeah, you end up implementing more, right? It's more code complexity. Yeah. Downside, this is quite a lot of extra complexity to maintain both versions. Okay, but basically I want to put this idea here because this is something I would approach. If I were to implement this, I would try to approach it this way because I think there's really value in tying it to Thyme, right? That the format is consistent. So the tools actually are consistent with what the game loads, right? That there's no disconnect. And I think this is very desirable, right? You don't want to like divert things, right? Re-implement things. You always want to reuse contracts, right? And not write them all new again, right? Then because then there's always a risk that there will be discrepancies, and if there are discrepancies, then it means there will be bugs, big bugs or small bugs, right? And so this must be eliminated. And if this loading was using the mesh geometry class directly, then there would be a strong guarantee that these things are tied, right? Anyway, I would just leave it here and just food for thought. But yeah, I think it will be possible. The chunk tree basically gives different possibilities here. Yeah. Good. I think that's all I need to say here for now about this. Good. Let me submit this review here. Okay. Then yeah. Good. Anything else? I think I can take a break now. We didn't get to write any code ourselves. Just a lot of talking, but that's okay. Okay, it's been 2 hours. Yeah, it's a good time to take a break. Then yeah, I wish you a great day or night until next time. Goodbye, and I hope I get rid of this hiccup. Bodily function is degrading. Yeah, I should spend so much time in front of the computer probably. Yeah, good. Have a good day. Bye bye.